expected result for a specific input values. This means when we want to run specific method with a specific input, what is the result that we are expected. The fixed values, the expected result added to input values to form test cases. In this stage, we have test cases that could run over the program under test. Okay. In the next stage, we should generate test scripts to so that it could run the tests or test cases automatically. The course and in next chapter we teach how we can generate test scripts in, for example, JUnit platform for Java code. In the next session we talk about the test scripts. If you have any problem with test scripts, please postpone your questions to the next lecture. This lecture just we define the approach, we explain the approach of model-driven test design. In the next stage, we should execute the tests over the program and the test, and record the results, the results of the test cases. And in the next stage and final stage, we should evaluate each test. We should compare the expected result of a specific test case with its actual result that we received in a previous stage by execution of a test case. So in this test case, we could find out which tests are passed or which are failed. Okay. So as I explained for you, in the first stage we should do some analysis tasks to extract structures from source code, and we should do some domain analysis to define some test requirements by expert users, by domain experts, and by the help of some coverage criterion. By the help of a coverage criterion, we could generate test requirements from model structure, and the refinement should be done to have a unique set of test requirements. And in the next step, we should generate test cases for covering all of these test requirements. And as I explained for you, in this stage, we should add prefix values, postfix values, and expected results to values to form test cases. So, as you know, as I explained in previous lectures, the test case is a multi-part artifact. Is an artifact that from 4 parts, includes 4 parts. The first part and the most important part of the test case is input values, test data. It's test data. The next one is prefixes. I explained this just a moment before. But what about the post phase? When we want to run some excuse me, some methods of our program. As I said, we should set the state of the program into an appropriate situation in which the program, in which the object could run the intended method. But when the test case is run, after running the test case, we should return to the previous situation. We should return to the situation before executing the test case. As you know, execution of a test case could change the state of the program. So we should return the program to the situation just before execution of test case. This should be done by, this could be done by fixed values. In this part of the test case, we define some values for some internal variables that reset the internal state to the T state of just before executing of the test case. The expected result explained for you before, and there is no problem about this concept. In automate, we should, as I said, we should generate test script to run test cases automatically, and in the next state we observe the behavior of the program for a specific test case, and we receive the test results or result, and I can evaluate the results in the last stage, and the results of this the activity in this level should be returned to other the team, especially for managers, test designers, or for developer team, and some other people such as users should be noticed from the feedback of the test, from the results of the tests. So if you have any question, you can ask your questions about this approach. The next slide we explain this approach more clearly by an example. If you have any question, you can ask your questions. You hear my song? The message? No song. Yes. Do you have any question? No question. So let me explain how we can use this approach in practice. In this slide, the 4 activities that I explained in previous lectures in software testing are stated in this stage. we just do a test design. Actually, in test design, the output of the test design phase is some input or test data. So in this phase or in this activity, we should generate our test data for our test cases. We should generate our prefix, the prefix of our test cases, the postfix and expected result. After this stage, we have some test cases grouped in test set. In this stage, we done the test automation activity, and next one is test execution, as you know, and the final activity is test evaluation, as I explained in the previous test. As you see, this approach rises the abstraction level, which make test design much easier. Why? Why much easier? Because I work with details of source code. We just work with some models, some abstract models, which hide the details of the code and drive the abstraction level. And we do test design more simpler. And how we can use this approach for generating test data or doing test design activity. In this example, you can see a Java method, a simple Java method, which returns the index of the element n in an integer array a. This is a sequential search method, simply, which states the index of element n in array a. For do this, as you know, we should scan the elements of array one by one until we find the element n. And if the n is not located in the array, ultimately we should return -1. For this, we use a for loop which scans the elements from 0, 1, from index 0, from the beginning of the array to the last one. When we find n in the array, we should return the index of n. This is a very simple method, and I want to explain you how we can do this approach for generating test cases, and how criteria could be used for generate test requirements, test automation should be done, how test execution should be done, and etc. Hope, excuse me. One of the structures you can extract from code, as you know from compiler course and other courses in your undergraduate stage, you know that the control flow graph is a suitable structure for analyzing or illustrating internal structures of the source code of a method. So in this case, we can extract flow graph from this code. Suppose in the first stage, in the start of the execution of this method, we be in location 1 or in state 1. In state 1, we have a counter I for the loop for which initialized by 0. In the next statement, if I is less than the size of array, we could execute the if statement. So in the next state of our control flow graph, we should compare I with the size of the array. If I is less than the size of array, or if there is another element in the array, we could test or compare that element with the value of n by if statement. So we can go to the state of the control flow graph and if statement executes. In this state, if the element n was found, we can return the index of n, the index I as index of element n. If not, we can return to the loop by the next element, and we run loop for the next element to to compare again n with the next element, and so on. We do this loop while the element n is found in this loop, or we reach the last element and don't find the element in the array. We go to the final state 5, and we should return -1. This is a control flow graph. This is a simple control flow graph which explains, which illustrates the internal structure of this method. In the next stage of the test design process, we don't need this method. We don't use this piece of code. So we just use this structure to design process. But for design test cases, we need some extra more than this structure, which one of them is a coverage criterion. Coverage criteria could be used for test generation from control flow graph. Some coverage criteria for graph structure, as I will explain in chapter 7. Some of them include node coverage, edge coverage, edge pair coverage, or مثلا, for example, pass coverage. These are some criteria for graph structures. In this chapter, we use edge coverage, for example, and edge pair coverage to generate test requirements. If we use edge coverage, we should design test cases that examine all that examine all edges of this structure. Okay. If we choose edge coverage as our coverage criterion, we have test requirements set that include all edges of the control flow graph. As you know, all edges of control flow graph are the edge from state 1 to state 2, state 1 to state 2, and state 2 to state 2 to state 3, and then state 3 to state 2 again. Each pair of these values show a specific edge of the control flow graph. So if our coverage criteria is edge coverage, we should cover all edges of this control flow graph that is equal to this set of edges. We should cover all of these edges to satisfy this coverage criterion, to fully cover this coverage criterion. On the other hand, we can use another or other coverage criteria in design test cases. For example, if we use edge pair coverage, we should extract all edge pairs from this control flow graph as our test requirements. So note that our coverage criterion is edge pair coverage, and our test requirements for this criterion is all the set of all edge pairs could be extracted from this control flow graph, which includes this set of edge pairs. All of the edge pairs of this control flow graph are listed there. The first pair is the edge pair which starts from state 1 and lead to state 2 and connect to state 3. The second one is the edge pairs which connected the state 1 to state 2 to state 5. The fourth edge pair is the one that connects state 2 to state 3 and state 3 to state 2. Okay. If you check this control flow graph, you could not find any other edge pairs which could not present, which doesn't present in this set. So all of edge pairs of this structure are our test requirements for coverage criteria edge pair, for edge pair coverage. This set shows our test requirement for edge pair coverage criterion. This set shows our test requirements for edge coverage. So now you should know that how test coverage criteria define our test requirements. In test design activity, we try to use test cases. We try to examine the method by some inputs that test all of these requirements, which could experience all edge pairs. For coverage criterion edge, we try to define a set of test cases, a set of inputs for this method. All of these edges could be covered by those test values. For designing test values, we should define how many passes should be executed to cover all of these edges, to cover all of these edges. So you can check that these three execution passes from this structure could cover all of the edge pairs. For example, if we run this pass, we execute the method for this pass, which start from state 1 and go to state 2 and go to state 5. Cover an edge pair and this edge pair, which is this edge pair, the second edge pair. And if we run the method for this pass, if we run the method for this pass, we could cover for example, we could cover, note that in this pass we go from state 1 to state 2, state 2 to state 3, and from state 3 to state 2 again, and then we go to state 5. So by this we can experience the edge pair that connect state 1 to state 2 and state 2 to state 3. 1 to 2. These edge pairs could be covered by the execution of this pass. And the next edge pair that covered by this pass is the edge pair that connect state 2 to state 3 and state 3 to state 2 again. This edge pair is covered. This pair could be covered again by this execution pass. And the last edge pair that could be covered by this execution pass, the edge pair that connect state 3 to state 2 and state 2 to state 5. This means this execution pass and these edge pairs, the edge pair that start from state 3, go to state 2 and then go to state 5. So by these two test passes we could cover some of these edge pairs, but not all of them. So, notice this test pass, this simple test pass, just cover the second edge pair. This edge pair. And the second test pass covered 3 edge pairs. Altogether we have covered 4 edge pairs by these test passes. And we know that we have 6 edge pairs. Now we don't cover these pairs. This pass cover the first pair and say 3 to 5 the as and then now we should another execution path by this structure so that it should cover these two edge pairs. For cover the third edge pair, we should define a path that connect state 2 to state 3 to state 2 to state 3 to state 4. So the next test path should be include these subpaths. The another subpath should be covered by the next path. Next test path is this edge pair. Start from state 3, connect to state 2. Excuse me. This start from state 3, connect to state 2, and then go to state 3. So if we run this test path, I could cover all of the edge pairs by these three test passes. If we add this path from the initial state 1 to state 2 and go to state and then return to state 2 and then go to state 3 and go to state 4, this is actually the last test pass. By these three test passes, we can cover all of these edge pairs. So the main problem in this stage is what test input should be fed to the method so that it could run these test passes. By which test input the method runs this path. Which is this path? The state 1 to state 2 and 3. We return to the code. Note that we want to pass this path. We execute this. We want to execute this execution path. So our array should be null or empty array. If we have an empty array, in the first we find that there is no element in the array and we just can go to state 5. So if we define an input set which consists of an empty array with any value for n, we could run this execution path. We could observe this execution path. So the first test case should be a test case that consists of an empty array with any value for n. The value of n, don't care. Not important. For the other test pass, for another test pass, the second test pass, which inputs are suitable? In this test pass, we should from state 1 to state 2, state 2 to state 3, state 3 to state 2, and then go to the last one, state 5. These paths should be executed. By which input values this path could be executed? This path from 1 to state 2 to state 3 to state 2 and then go to the final state. when we can reach to this state? If I have an array which not include of element n, we can reach this state. This state shows the element n is not located in array A. So the first thing that use it to design our test case is that our test input for this task, our input array should not include the element n. The second thing is that this task just execute the for loop one step, one bar. We have a one bar. So our array should have just a one element, and that element should be any value except n. So the next input value could be array with